This video is going to discuss dividing radicals. And at first, it's going to look a lot more like simplifying than dividing. The rules that we're going to use today, or the rule, is the quotient rule. So for dividing radicals, it tells us to divide the coefficients and then use the quotient rule, and then we'll simplify. Well, the quotient rule is just that the nth root of A divided by the nth root of B is equal to the nth root of A divided by B. And it's important to know that you can do this both ways. You can, combine them and uncombine them, however it's convenient for you. This rule says that you can switch it back and forth, not that you just have to do it one way. Okay? So, let's go into an example. Number 1 on your worksheet is 12 times the square root of 160 over 2 square root of 5. So it says divide the quotient, or divide the coefficients and then use the quotient rule. So we have 12 divided by 2, that's 6. And the quotient rule says we can take 160 divided by 5 and put that under a radical. And 160 divided by 5 is 32. Then we're just going to simplify this. So this is going to be the square root of 6 times the square root of 32. But we want to break down the square root of 32 into a perfect square times something. So we're going to do the square root of 16 times the square root of 2. Because the square root of 16 is 4. And so now we can combine everything to have 24 times the square root of 2. So not too bad. The next example I'm going to do with you is problem number 3, and this one has variables in it. So I just kind of wanted to do this one to remind you about exponent rules. So it says to divide coefficients, but we don't have coefficients in this problem. So we're going to start with the quotient rule. So the quotient rule says we can rewrite this as x cubed y to the 9th over x squared y to the 5th. And do it like that. And then we know how to simplify this using exponent rules. Whenever you divide with exponents, you subtract those. So we're going to get the square root of x to the 3 minus 2, which is 1, so that's just x, times y to the 9 minus 5, which is 4. So we have the square root of x, y to the 4th. Then we want to simplify this radical. So we would have square root of x times the square root of y to the 4th. Well, the square root of x is already simplified, so we'll just bring it down. But the square root of y to the 4th, remember that when we do this, we do 4 divided by 2, and that is an even 2, so that means that our radical will disappear, and we'll just have y to the 2nd power, because 4 divided by 2 is 2. So now, when we recombine those, we get y squared times the square root of x, and that's your final answer for this problem. I'm going to do one more example of these with you. Number 5 is an example where I just wanted to show you that you can split this up into the square root of 48 divided by the square root of 16 and solve it that way too. And in some cases, when you have perfect squares, this can be helpful. However, in this case, it's just as simple to divide 48 by 16. So that's what we're going to do. And 48 divided by 16 is just 3. So we get the square root of 3. And 3 is already simplified, or is not divisible by any square root. Perfect squares. Whew. So that's your final answer. All right, so here is where you can pause the video and complete the rest of numbers 1 through 8. Those are all similar problems. We have done 1, 3, and 5 together. So yeah, pause it if you would like to finish those right now. So what makes dividing a little bit more complicated is that you are not allowed to have a radical in the denominator of your answer. So if you see here, we have a square root of 5 in the denominator, and that is not allowed, okay? It's just not proper form. So anytime that we have a radical in the denominator, we have to rationalize. And the way that we do that is by getting the radical out of the denominator. How do we do that? We multiply the numerator and the denominator by the radical. And this rule is for monomial denominators. We'll go over binomials in a minute, but basically that means that there's no addition or subtraction in the denominator, only multiplication, and that's what this is, 2 times the square root of 5. It's one term, that is a monomial. So we are going to follow the rules here. It says multiply the numerator and denominator by the radical. So the radical is the square root of 5. So we're going to multiply both the numerator and the denominator by the square root of 5. But something I want you to notice about why we choose to do it this way. If we just look at this, the square root of 5 divided by the square root of 5, that would just equal 1. We're not going to simplify it that way because that will defeat the purpose. But I want you to notice that we are just using a special way of writing the number 1 to get this in the right form, because multiplying something by 1 is not going to change its value. But using this special form of the number 1 is going to let us change the form instead of the value. So let's keep going. When you multiply fractions, you just multiply straight across. So 3 times the square root of 5 is 3 radical 5. 2 square root of 5 times the square root of 5 is 2 square root of 25. But the square root of 25 is 5, so we're going to get 3 square root of 5 over 2 times 5. And 2 times 5 is 10. And then we check to make sure these can't be reduced, and 3/10 is not reducible, or whatever you want to say. So that's your final answer, 3 square root of 5 divided by 10. And if you were to type this in your calculator and this in your calculator, they would give you the exact same numerical value because all we did was multiply by 1. So we'll do one more example of monomials together before we move on to binomials. So in this one, I wanted to remind you about the quotient rule, okay? Because we do have a radical in the denominator, but we only want to multiply by that one. So let's rewrite this as the square root of 8 times the square root of 15. And now it's very clear what radical is in the denominator. And we want to multiply top and bottom by the radical that's in the denominator. So this is multiplication. 8 times 15 is equal to 120. So we get square root of 120. And then the square root of 15 times the square root of 15 is going to be the square root of 215. Sorry, that was 225. But this is really like saying the square root of 15 squared, and that's just going to give us 15. So the bottom automatically reduces back to 15. And then the square root of 120, we want to break that apart into 2 different radicals. The biggest perfect square that goes evenly into 120 is actually just 4. So we're going to get the square root of 4 times the square root of 30. Square root of 4 is 2, so we have 2 square root of 30 over 15. That is not able to be reduced any further, and that's your final answer. So here is where you can pause the video and finish 9 through 14. We've done 9 and 10 together, and the rest of them are similar to those problems. The next topic we need to tackle, and this is the last topic for this video, is when we rationalize a binomial denominator. So to rationalize a denominator that is a binomial with a radical in it, so binomial means 2 parts. We have this part and we have this part, and we have addition or subtraction in the middle. That's what defines a binomial, 2 terms. And we want to multiply the numerator and denominator by the conjugate. And the conjugate is the same expression, but with the opposite sign in the middle. You only change the middle sign. You do not change any other signs. So what that means is we're going to multiply top and bottom by 4 minus the square root of 2. And remember, These have to be the same because it has to equal 1 so that we're not technically changing the value of this expression. All right, remember that when we multiply by a binomial, we have to distribute here, and we're going to use the FOIL method here. So 4 times 4 is 16. 4 times negative square root of 2 is negative 4 square root of 2. Divided by 4 times 4 is 16. 4 times negative square root of 2 is negative 4 square root of 2. Square root of 2 times 4 is plus 4 square root of 2. And then square root of 2 times negative square root of 2 is negative square root of 2 times 2, which is 4. All right, so this is where we need to pay attention to why we multiplied by the conjugate. If you look at our middle terms, negative 4 square root of 2 plus 4 square root of 2. That's going to give us 0. Okay, we have a negative and a positive of the same value, so that will give us 0. All right, these cancel out to be 0, and that is the whole reason that we use this conjugate number, because it also forces this number to be a perfect square. So let's look at what we've got left before we get too far gone here. We have 16 minus 4 square root of 2 divided by 16 from here, and then those equal 0 minus the square root of 4, but we know that the square root of 4 equals 2, so we have 16 minus 2. So let's simplify again, and remember that these cannot be combined because they're not like terms. This 4 is attached to that radical. 16 minus 2 is 14. And then we have to look at all 3 coefficients or constants and see if they have any common factors. And they can all be divided by 2. So to simplify and get our final answer, we are going to have 8 minus 2 square root of 2 divided by 7. And that's your final answer. Let's do another one of these. All right, we have a radical in the denominator, and we need to multiply by a conjugate. All right, so the conjugate is, instead of 6 minus square root of 5, it is 6 plus square root of 5. And we have to multiply top and bottom by the same number. All right, 2 times 6 is 12. 2 times the square root of 5 is 2 square root of 5. All right, that was really messy. I had to fix it. Now we are going to multiply the bottom, and we use the FOIL method. So we do 6 times 6 is 36. 6 times square root of 5 is 6 square root of 5. Negative square root of 5 times 6 is negative 6 square root of 5. And negative square root of 5 times positive square root of 5 is negative square root of 25. Now, if we look again in our middle terms, those are going to cancel, which is the whole reason we used that conjugate. So let's see what we've got left. 12 plus 2 square root of 5 divided by 36, and we have minus the square root of 25, but the square root of 25 is just 5. So we have 12 plus 2 square root of 5 divided by 31, and that is it. That's your final answer, because 12, 2, and 31 do not have any common factors, so this cannot be simplified any further. Here are the remaining answers to your worksheet. I've also posted them in your binder, and the binder has all 20 in one place. So you guys have a great day. Thanks for watching.